Here's a very common exercise that I want to show you how to solve just in case you ever see this type of problem. What we have is an equation. It says x times the quantity x plus 4 equals 12, and we like to solve this by factoring. Well, the thing is the left-hand side is already factored, so it feels like there's something we're supposed to do right now with this factor of x and this factor of x plus 4. But the thing we have to be careful about is that this is not set equal to 0. And if you want to solve an equation by factoring, it has to be set equal to 0 first, because what you're trying to use is something called the zero property that we talked about in an earlier video. So what do? Can we subtract 12 right now? Well, I suppose you can, but it wouldn't look that great, because you'd have x times x plus 4 minus 12, but that doesn't really look that great, and it's not really clear what we would want to do, and even though that would be set equal to 0. So what I think we can do is let's go ahead and distribute this guy out so we can see all of our individual terms, and we get x squared plus 4x equals 12. Now we'll set it equal to 0 by subtracting 12 to the left hand side. We'd get x squared plus 4x minus 12 equals 0, because so now it's equal to 0 on the right hand side. And so now, since we have our quadratic equation set equal to 0, now we can factor it again. See, what happened was this was factored a little too prematurely, so we actually had to distribute it out to see our individual terms again, then set it equal to 0, and then refactor it. So let's see if this guy factors. I think I'll factor this one just using simple trial and error. So we have a product equal to 0. These two binomials are going to FOIL to give me this quadratic. This would have to be an x and an x. That's the only way to get x squared. And then in our last two spots, we want something that multiplies to negative 12 that will add to positive 4. So you can make a little chart of things that multiply to 12. Could be 1 times 12, could be 2 times 6, could be 3 times 4. And I'm looking for one of these factorizations that will add to a positive 4x if I could have the signs potentially be anything I wanted. 1 and 12, it doesn't matter what the signs are, that will never add to a 4. Same thing with 3 and 4. But a 2 and a 6, now I'm not saying that 2 and 6 are the definitive correct numbers to plug in here, but I'm saying they're worth a closer look, because there's at least a chance that these could be the two correct numbers. So let's see, to add up to a positive 4x, it would have to be plus 6x and minus 2x. But again, I'm not saying that's the correct answer, because I also have to make sure that it multiplies to negative 12 as it should. And negative 2 times positive 6, if you FOILed these two, that actually would give you negative 12. So we're good to go. These two binomials FOIL to give you this quadratic equation. So that's how we do factor by trial and error. You basically just try to think about what you could have, what two binomials would FOIL to give you your quadratic. So anyway, once we have a product equal to 0, we'll take each of these individual factors and set them equal to 0. If x minus 2 equals 0, if you add 2 to the right hand side, you get your answer, your solution of x equals 2. So I'm going to circle that. There's one solution. And then you'd also take x plus 6, set that equal to 0, and we'd get x equals negative 6. So that would be our other solution. So these two guys, 2 and negative 6, would be the solutions to this original equation that we have here. And you can verify this. It's very easy to check. Just take either of these numbers and plug them into the equation and see if it makes it true. Let's try plugging in 2 for x. 2 and then 4 and 2 make 6, and 2 times 6 equals 12. So this is a solution, and if you tried the same thing with negative 6, plugging that in for x, you would also get 12. So that's how you find the two solutions for this equation here. So we distribute the terms, get our individual terms, then set it equal to 0, then refactor it, and then set those individual factors equal to 0 to find your solutions.